tree, Control N. So there are various reasons you need spanning tree protocol. Okay, spanning tree protocol. It is called
Are you sharing
STP.
that?
I'll share my screen now. Yeah. So today we will discuss about spanning tree protocol. Okay. So in brief, we will call it as STP. But the reason we need STP is to break broadcast loops. Okay. So do you have any question regarding broadcast loops? I will explain what broadcast loops are. If you look at these two diagrams next to each other, okay, they are almost the same kind of configuration, right? If you observe these two here, these both are the same network. But if you observe here, there are so many green broadcasters. So what the blinking green LED status suggests us is that the switch ports are all active and forwarding. Okay. So let me compare with the same setup which has spanning tree enabled. You see, some of the ports are off or down, but some of the ports are forwarding. The amber indicates that not necessarily means the switch port is down. It also means that the spanning tree is currently blocking the loop and it's not forwarding. If I disable the spanning tree on all the switches, this is how the condition looks like. Now what I'm trying to explain here is, for example, take this diagram. Okay, let me take the screenshot of this. If I take this diagram, see here, I'm going to connect a PC here. Okay, Kishore, Kavya, I'm going to connect a PC here, one more. Just imagine, and one more PC here. Okay, let us call this PC as A. Let us call this PC as C. Just imagine if A is trying to reach the PC C. Now it will send a ping request on this port. As soon as the ping request is received by this switch, the ICMP packet, it is broadcasted to all other switch ports except to the switch port where the packet came from, right? Because this is the source port. This is the source port where the packet received. So the switch is clever enough to not broadcast the packet in this port, but it will still forward the packet to the other ports it is connected to. And the uplink switch will receive the broadcast request. It will forward to this switch again, and it will forward to this switch again, and then forward to this switch and this switch, right? Except for this port, because why? This is the source port where the packet came from. So it will broadcast to all the rest of the ports. Now this switch will also again receive the packet, right? It will send to this port, this port, this port, and this port. Now this packet will go to this switch port, and this will again forward to this switch port where the actual destination is connected to. Now the problem is, look at the middle section here. If you observe the section here, the packets are coming this to source port and they are leaving this port. And this packet, once it comes to this port, what's happening? It's again went to the switch where it received 2 hops ago, right? Again this packet is coming to this port, again this packet is coming this port. Now let me represent the second loop in the blue sketch. So this packet is again coming here. This packet is again coming here, and this is coming back here. See the blue flow here? The blue is forming a loop here, right? Do you all agree? Look at this triangular setup here. Yes. There is a loop, right? So this is for just one PC. Imagine there are 200 PCs. Imagine this PC is also trying to communicate with this network at the same time. Imagine how many broadcast loops they are forming. This is a big headache for the switches to maintain the broadcast loops. Our design consideration suggests to have a design redundant connection like this. And it also suggests to have a hierarchy from core to distribution, from distribution to access. There is nothing wrong with our engineering here. The design part is flawless. The only part is with the switch mechanism. Switch, as is a general habit, it creates a broadcast request to all other ports except from the source port where it received the request from. So this is the reason why there is a loop forming. If I go back to the engineering setup where I have enabled spanning tree on each switch port, I will take the screenshot of this again, I'll paste it again. Let us see how the packets go here in setup, okay? Here, this PC goes to this PC, right? And this switch, will it forward to this port? No, because this port is disabled, but it will forward this port. Let us assume it is trying to reach PC2, okay? Now, after reaching this PC, this switch, it will forward this port and this port, right? What will happen to this packet coming here? It will come to this switch. And this switch will forward to this PC and this port. But this port is disabled, so this packet is dropped. And this PC reads the destination address and it knows that it is not designated to its. So this will also drop. So where the packet goes then? There's the other packet going here to the core switch. The core switch will send broadcast to all the ports. Now, this port packet will come here and it will again forward to this packet. But you see here, the other end of this port is not forwarding any traffic. So this packet is dropped. And also it will forward to this port, but other end of the port is not forwarding, so it will also drop. Now look at this packet. It is going to this switch, and it's being forwarded to this port, and this port. But this port, you see, it's down. It will drop. This port, it is down, so it will also drop. Again, this port will go this forward, but unfortunately, this port is also dropped. Also, it's dropped, but so this will also drop. But how will this PC get the traffic? Look at this here. There is still it's sending it to the secondary core. And it's also still sending to this part. Right? So this packet will come here and it will forward here. It will forward here. It will go here and it will forward to this PC and this PC will also drop. And this packet is going here and it's ultimately received. You see, it went through almost all single mesh, but it cleverly, the spanning tree protocol dropped all the port packets. But ultimately, our goal to deliver the packet to the PC3 is finished without any loop being formed in the network. You understand why we require a spanning tree protocol? I will show you again here. Let me send the packet from here to this switch. Okay. It will probably not forward because we did not configure any VLAN. But still we will see how the broadcast terms are created at each end. Okay. You see how it's broadcasting to all its switch ports. Let's see. This will be dropped here. It will show a mark here. See. It is eventually dropped because we didn't configure this in access VLAN. Okay, probably I might have configured it, but let's see the simulation here. If I try to communicate from PC to PC, then it will work. Or maybe not work because I did not configure inter-VLAN routing. Anyways, you understood the concept, right? How the loops are being avoided here by using a spanning tree protocol running in it. So all these switches have spanning tree in it. Okay, enable, show, run.
Harsha.
Yes.
I have a small doubt. you said that by enabling spanning tree protocol, you are avoiding the loops.
Right.
But few ports in the diagram are already not enabled.
No. See, I'm not enabling. So what is your question? You are saying that
Yeah,
I am
because of
I'm
the
running.
yeah.
No, spanning tree algorithm runs on every switch. It will decide which port to keep on, which port to block, which port to keep forwarding, and which port to block. You understand what I'm saying? The spanning tree, it is not my decision. It is run by spanning tree algorithm. It is a very complicated algorithm. So this is one of the best top pioneer algorithm that we use in networking. This is very complicated, right? So your question is why some ports are forwarding, why some ports are blocking? Though we did not configure spanning tree, is that your question?
Yes. I mean, not with that. My question is that. Okay. Now understood what you're saying. That when we configure the STP on this network, so it automatically takes the decision to enable which port and to disable which port, right?
See, SPT is configured by default on all switches, especially PVST on VLAN 1. When I say PVST, it is per VLAN spanning tree. Okay? So when you go to the switch, right?
Yeah.
So show run. What is the VLAN you will have on each switch? VLAN 1, right?
Yeah.
So spanning tree is configured on all VLANs by default. If I create configure T, VLAN 2 and show spanning tree VLAN 2. Spanning tree exists for VLAN 1, so spanning tree VLAN 2. No spanning tree instance exists. Let's see why. So if you look at here, initially the spanning tree is by default configured on VLAN 1. Okay?
Yeah.
If I configure a new VLAN on this switch and again this switch, let's see if I configure VLAN. I will show you in a brief second how I configure VLANs and let them select the root VLAN. Okay? You know what I'm saying? How the spanning tree will work on it once I configure the VLAN. Initially, it should take, whenever I create a VLAN, right? It should take, by default, it should be configured with spanning tree. Okay? So initially, when I configure any VLAN, it will be by default. It should be configured. On these switches, I am unable to see it. Maybe because I will show you. I will go to the core switch. In real world, the switch works like this core switch. Okay. So spanning tree VLAN. Okay. VLAN 1. Let me configure a new VLAN. Configure to VLAN 2. Okay. Show spanning tree VLAN 2. So spanning tree, this is interesting. I will show you a real world switch. Let me pause this recording. Okay. Spanning tree default value is 32768. So I did not configure any spanning tree on this guy, right? Show VLAN. I did not configure any spanning tree on this VLAN.
Yeah.
Sorry, VLAN 1, right? So show spanning tree VLAN 1. It should take the default spanning tree value, which is 32768. And it will add 1 to it, and it will give a final bridge priority as 32769. That is because VLAN number 1, right? It will add that 1 to 37. If I configure, I'm going back to my original switch. I will explain to you what is spanning tree priority, how the spanning tree priority works, what is a designated port, what is a forwarding status, what is blocking status, and what is the root port.
Okay.
Okay, I will explain you all these things in a brief second. So talking about, can you all have to assume our entire concept that spanning tree is by default created for each VLAN on the switch with default value plus VLAN number value. Okay, for example, if the VLAN is VLAN 2, what will be the spanning tree? Priority 32768 plus 2. It is equal to 32770. That's how it will be. Okay.
Yeah.
Okay. So read the value. I will be back. Okay. Someone asked why we are using spanning tree for. It is for breaking loops, right? So it is a loop prevention algorithm. I will briefly go through the slides. So redundancy in a network is extremely important because redundancy allows network to be fault tolerant, right? So that we have discussed at the beginning of this class, that we have engineered the network design with a lot of redundancy. For example, this switch has 2 redundant links to the distribution. This switch also has 2 redundant links to distribution. And the distribution has 2 links not only to the core, but also 1 redundant link going to the secondary. Just in case if it lost both the links, it still have the way to get to the core using this link. But the cost, the result of having so many redundant links, the drawback or the setback of having these many links is that it creates so many loops. That's what we're talking about here. The redundancy network is extremely important, but redundant topology are based on which are susceptible to broadcast storms that we have discussed in here, right? So in our paint, the screenshot we had. You see here, we have so many broadcasts going on. That has created so much of broadcast storm, right? Earlier, before this presentation, we have seen how the packets are going through all the way, and they created a lot of loops, right? So many, not just because the loops have formed because of so many broadcast storms. They're both meeting each other in the same nodes, network nodes. So because of this broadcast storms and multiple frame transmissions, what happens? There is a big, huge loop. So the network redundancy requires careful planning. When I say careful planning, of course, the redundancy comes with so many redundant links, and you can see so many triangles. This is one triangle, this is one triangle. Triangle is nothing but a big loop, right? And here you see one big triangle again. Here itself I am seeing 3 loops. And here there is one more triangle, 4 loops. Combine all these 4 triangles. How many loops you are getting? You are getting 4 to 4 combinations. Around 16 broadcast storms. And 16 loops in together, right? So spanning tree protocol is used in the switching networks to create a loop-free topology from a physical topology that has loops. So you have to maintain redundancy, and at the same time, you also have to take care that the looping is not formed. So out of these 4 triangles, if you combine, there is one big loop here. There is one big loop here. So 4 multiplied by 4, 16 combinations. So you should bring down the port. So the algorithm should be clever enough to bring down the port while assuming at the same time, while considering that it is not breaking up the network communication. So each switch has a way to reach to the root bridge or to the core or to any part of the network in the most optimal way, while not dropping the packet or not while not entering into any broadcast stop. So how that is achieved? So to achieve that, there is one simple way. We have a broadcast arm here. Just consider these two switches. These two switches have a loop, right? So the easy way to bring down this loop is how? For example, let's go to the next diagram. Okay, you see that this is the unicast mechanism. So, and it has a way to reach the router back again, and it has a way to go back to this message. So there's one way to bring the loop back. You can break this port, right? You can switch off this port. You can keep this in a blocked state. You can keep this port in the forward state. That way you can prevent this entire loop here. While you are blocking this port, you are still able to reach from this port to the server and also this router, right? There's no requirement for the switch to go back here and reach the server this way. It will be a long loop, and it also will be a longer path for this packet to reach from here to here just to reach this router. So spanning tree calculate all this map, and it will make sure that this path is too long enough for this switch to reach here. And also it makes sure there is a way for the switch to reach this switch while not dropping the packet. So it keeps the redundancy intact. Just in case physically if this port goes down, it will immediately activate the switch to this port to forwarding state. So it has also that inherent mechanism to move the port from blocking state to forward state as well. So just don't think that once this port goes to the blocking state, it will remain forever in blocking state despite we have two redundant paths from this switch to this switch. Remember, if this physically goes down, spanning tree sends BPDU, Bridge Protocol Datagram Units, okay? BPDU will continuously poll the switch status also, port status. So, once this port physically goes down, BPDU will recognize that it goes down. It will give learning state, forwarding state, all those for like 15 seconds. Then it comes back and makes it a forwarding state, which were earlier in blocking state. So spanning tree will dynamically change the state of the ports. We will see that how it happens in a very short while, okay? You see there is a one loop here in a triangle. You can see one loop here. When you apply the spanning tree, that loop breaks. You see the triangles are all gone. They are just one links. But just assume if this link is going down, just in case, this guy here, this link, it will go into forwarding state, it will come into the picture. Okay? So do not confuse the spanning tree protocol for another STP, which we also use as short notation, which is a shielded twisted pair. But STP is most widely called. STP shielded pair is only used when you are referring to a cable. Okay? So remember, when you say STP, spanning tree protocol is what we mostly use. This we just explained. So two slides ago, I explained how did it block the below port while considering above port. Just because it has a long distance reaching this node, right? So how it considers the path cost. So if the link speed, for example, you have two redundant links to the switch, uplink switch. If this link speed is 10 Mbps, if this is 1 GB, obviously which one has a higher bandwidth? The 1 GB one, right? So the less the cost it will prefer, the better the path. The cost, for example, say this route is 10 Mbps and this is 1 Gbps. Which path takes longer time to deliver the packet? Say example, this is a 5-lane road and this is a 10-lane road. 5-lane road has more chance of congestion. So traffic is having a high chances that 5-lane road cannot accommodate same amount of traffic as 10-lane road does. So spanning tree obviously prefer the 10-lane road. We obviously prefer the road, right? If you have a chance to go by 5-lane road or 10-lane road, you will obviously prefer 10-lane road because it will be easy to pass by. The traffic, no matter how congested it is, you still have some room to drive. There is a more chance of traffic congestion in a 5-lane road compared to 10-lane road. The same applies here. 10 Mbps, 1 Gbps. If you have a chance to pick from 10 Mbps or 1 Gbps, you always go for 1 Gbps because the link cost is 1. So going back to the big picture here, if spanning tree wants to block this port or this port, which port, it will prefer first that has higher bandwidth. Okay. Here you see this port is blocked, this port is forwarding state. So spanning tree definitely calculated that probably this port has much better value. We will also work on that. Okay. We will manually, what I will do, I will give this switch as a different, much better bandwidth. And I will give this one as a lesser bandwidth. I will manually alter the bandwidth value. You will definitely see this spanning tree going from here to there. Okay. Let's stop this. You will definitely see this port going amber and this going green. We can also modify the bandwidth and to see if the spanning tree mechanism works cleverly. Okay. So that is what we are talking about, the past cost. And it will also, in the process of selecting a particular port as a root bridge or a forwarding port or a blocking port, it will consider a particular switch as a root bridge, okay? And it will also use root path cost and also the port ID. It will consider all these factors in spanning tree election. And once the selection is done, it will select a root bridge. It will also select the forwarding port. It will also select the designated port, root port. All this I will explain you in the next example. So this slide basically talks about how the spanning tree mechanism works and what are the elements of spanning tree. Root bridge is one element, and while considering the root bridge, it will also consider the next root port by using the root path cost. I will explain in a second what is the path cost and also what are bridge protocol datagram units are, BPDUs are, what is the port ID. I will explain all of them. So here we are discussing about the selecting a root bridge. There is a clear definition of how the root bridge is selected. Okay. So I already explained the default priority of spanning tree is 32768. Okay. And a switch based MAC address. If it is a per VLAN spanning tree, it will add one value to 32768. Since here it is we are selecting on the entire bridge, it will consider the MAC address. I will explain you all this thing in the next slide. Okay. That's the reason I asked you to go through this, to read this slide so that you will have some understanding before I explain this. So this is BPDU. Before coming to BPDU, I will explain how spanning tree mechanism works. For that, I have handwritten a slide. Okay. So you all have a look here. 1 second. You have all have a look here. Okay. 1 second. Okay, so you look at here, this diagram, what you need to understand is, let's go full screen. Okay, in this diagram, what you need to understand is, here you have switch B, okay? Are you able to clearly see and read the switch name? Switch B here, this is switch A, this is switch C, this is switch D, this is switch E. A, B, C, D, E. Okay? Let us call this as switch F, whatever it is. Okay, Kavya and Kishore. So, here we have so many loops, right? This is one loop. this is one loop and this is one big loop, right? So I call this as switch A, switch B, switch C, switch D, switch F, switch E. And I also return the MAC address of each switch, okay? The switch A MAC address is 0000.A, okay? So switch A MAC address is 000.00.00A, okay? Going back, what is the switch B MAC address? 00B, okay? This is hexadecimal, right? So switch B MAC address is 00.00.00B. What is switch C MAC address? All the way to .000C, right? And what is the switch D MAC address? 00D, okay? 00D. What is switch E MAC address? I gave it as 003, okay? Capsule. Switch E that is 000, sorry. So MAC address of these switches are given here, right? So I'm going to ask you a question here. So sorry, not E, this is 3. So of all these MAC addresses, which is the smallest MAC address? Hexadecimal, you know, right? Hexa to binary or decimal conversion.
It's I think the last one.
Yeah, this is the small, because after 10, after 9 hexa you get A, right? After A you will get B. So A is definitely greater than 9, B is definitely greater than A, C is definitely greater than A, D is greater. So hexa you have up till 16, right? So it's a combination of digits, digits and numericals. In hexa 003 is smallest. So since the switch E has the lowest MAC address, what is the root bridge now? Bridge is nothing but switch, right? So what is the root bridge now? See here, bridge ID is least. So switch E has become root bridge. You are following me? There are A, B, C, D, E, F. There are 6 switches. In these 6 switches, spanning tree algorithm is configured by default. That is basic rule. Spanning tree is by default configured on VLAN 1, native VLAN 1. Now we have run spanning tree on all these switches. So which switch it will pick as root bridge? The switch that has lowest MAC address. When you can ask me this question, you are saying that spanning tree is configured by default on our switches. Why cannot it pick any switch? Because the default value of spanning tree is 32768. Why cannot it just pick any switch? Because all the priority is by default 32768, 32768, 32768, 32768. Why did it choose switch E? The reason it choose switch E because switch E has the least MAC address. So bridge ID is chosen. Now going back, switch has so many ports, right? Switch has so many ports. For example, this is the root switch. Now let's go to its nearest switch. Switch D. So switch D has 1, 2, 3. So it has 3 ports. So these 3 ports, which will be forwarding, which will be blocking? Can you guys guess? See here, there is a very clever mechanism. Spanning tree not necessarily, even though the switch has 3 ports, will block certain port to avoid loop. Remember what I have said? Before blocking any port and making it blocking port and stopping it from forwarding the traffic, spanning tree will consider which factor, which element, path cost. For example, I will take very far switch. Okay, I will take this switch B. It is a very good example. So switch B has 3 ports. Okay, switch C has 3 ports. So the spanning tree, how it will select a root port of these 3 ports. Spanning tree will select, after selecting a switch, it will select a root port, and also it will select a designated port. I will talk about designated ports are nothing but all the ports of root bridge. So switch P root bridges are all designated ports now. They will be either be forwarding or blocking state. That it doesn't matter. We are now talking about not about forwarding or blocking. We are talking about root designations. So either, is it a designated port or is it a forward or it is a root port? That is only we are looking at now. So for example, instead of looking at the switch ports, now look at the switch, the port cables or the port path. So for example, there are 3 ports on this switch B. Now spanning tree has to somehow break this big loop here. You see here, look at this network circuit. The packets will go here and come back here, right? So this is a big loop, right? So somehow we have to break this loop. So which port to block? So spanning tree will go to each port of the switch and decide which port to block to block this, to break this loop. Okay? So spanning tree will come to the switch first, and it will calculate the path cost of each path. For example, spanning tree will come to this port first. It will calculate the path cost. From here to this port, the path cost is 19. You see here how the path cost is 19, and from here to here, the path cost is 4. Now you can ask me why you gave path cost this 4 and this 19. See here, this is fast Ethernet connection, F0. Fast Ethernet connection is how much, what is the speed of the fast Ethernet connection? What is the speed of gigabit connection? Giga is 1 Mbps. And fast Ethernet is, it can be 100 Mbps or 10 Mbps, right? The basics. So fast Ethernet connection here and gigabit connection here. So which one will you choose, fast Ethernet or gigabit connection? Obviously gigabit, because it has less path cost. Gigabit has a bigger bandwidth. So packet, it will always spanning tree will prefer to go here. Now, it will calculate the path cost. Now you ask me, what is the path cost? I know here the path cost is there. This is 419. You will ask me what you are trying to calculate. See here, we are trying to calculate root port to breaking this loop. See here, if you consider the root bridge here, the root bridge is here. These are 2 designated ports. What spanning tree will do is, it will calculate the path distance from that port to the designated port, which is here. So 19 plus 4 plus, what is the path cost of this one? 4. What is the total we got? 19 plus 4, 23, 23 plus 4, 27. So this path has 27 as the cost. Now again, this will remember the path cost from FA01 of this switch is 27. Now it will calculate path cost from this port. 4. What is the path cost here? It will come here, right? 4. And again it will come here. 4. What is the path cost total? 12. It is bigger than, it is smaller than 27, right? So obviously it will prefer this port. Now still it will, before making it as root port, it will have to select this port and see, calculate also, right? We have still more ports. And it will go to this port and it will calculate the path cost 19 plus 4 and whatever path it takes. It is still greater than this port. So it will definitely not make this port and this port root ports. So this is being now made as root port. So this port will always forward the traffic. Okay. Now it will also calculate the pathcast for this port. Now since this will go from 4 to 19, so 19, this is very expensive, it cannot go this way. So what it will happen, this will become a forwarding port for this root port. This port will become forwarding port for this root port. Now come back here. For this port to get to the network, what is the cost? 4 plus 4. 12. 8, right? So this port will be not blocked. Why? I will tell you why. This port, to reach the designated port, the cost is 19. So there is a big loop here. So spanning tree will try to block this port, but wait there. It will not block that port. Why? Because it also has to check this port. This port pathcast is 4, less than this one. So go ahead and block this port. So this block is now blocked. So this loop is now broken, right? There is no more loop because we broke this port. In this loop, we've broken this port. So this port is broken. So no more loop in this port. And again, it will run the same mechanism also. Can you tell me what is the near pathcast of F0 to designated port? It will go from here to here, 19, 23, 23 plus 4, 27, because this is blocked, I cannot come here. 27, it will come here, 31. Now let's see this port cost here, 4, 4, 12. So obviously this should be blocked, right? All these ports has less distance. This port also, 4, 4. This port also, 4 plus 4 plus 4, 12. 27 is still, 12 is still smaller than 27. So obviously this port is blocked. So this loop here is also blocked. See how cleverly spanning tree is running? It will calculate, it will also select which port to choose basing on the pathcast. Now you might ask me, what if the pathcast of this one and this one and this one are all same? How it will do the tiebreaker? You know how it will do the tiebreaker? Kavya, can you guess? Kishore, can you guess? If you have the same pathcast from this ports, how it will do the tiebreaker?
Maybe the one that has the gigabit side.
I'm sorry?
The side that has the G01, that side maybe it will pick the gigabit side because the cost.
See, pathcast is same. No, I am saying if the pathcast is 4, this is also 4.
Yeah.
Then see the cost. 4 plus 4, 4. 12. If you go from here also 4 plus 4 plus 4, 12. So between these two, which it will tie break? I will tell you which it will tie break.
It will choose the nearest switch. Okay, I don't know.
No, it is nearest switch. See, the path from this port to this root bridge is, this is root switch, right? If you go from here, it's 4, 4, 4, 12. If this one is also 4, assume this pathcast is also 4. If it goes from here, here and here, 4 plus 4 plus 4, 12. Both are having same cost, same distance. How it will choose? There is a clever way to break that also. See, each interface will come up with what? MAC address. Not only switch. Each switch will also come up with a MAC address. So the switch that has interface that has least MAC address, it will go ahead and choose that one as the root port if there is a tiebreaker. You understood?
Yeah.
So between these two ports, which it will choose? Whichever it has, the lowest MAC address. If there is a tiebreaker, that is one way the tiebreaker works. You understood how the spanning tree election mechanism works? Yeah.
I didn't understand the fast forwarding port.
Fast forwarding port? There is no fast forwarding port or blocking port. See, you are blocking this port. That means it is not forwarding the traffic. You did not block this port, so what is the state it is in? Forwarding. You did not block this port, so forwarding. Forwarding means it is passing the traffic. It is forwarding the traffic. See, this state is in blocking. So this is this port is in which state? It will be in forwarding state, but it will not able to forward the traffic to the opposite port. So you can find two ports of the switch forwarding. For here look at this, all these three ports are forwarding. It doesn't care if the opposite port is blocking port state or not.
Okay.
So what is happening here? You can look at here. You see? So all these ports are forwarding on the switch. That doesn't mean it's causing loops. Somewhere else they are blocking. You understood, right? So this port is in forwarding state. This port is in forwarding state. This port is in forwarding state. You understood?
Yeah.
This port is in forwarding state. This port is in which state? Can you tell me?
Those are designated ports.
Exactly. These two are designated ports. So the traffic, they will try to come to this direction. But obviously this is also forwarding. But on the spanning tree protocol, you will see them as designated ports. I will show you. If I go here, I'll say N. Why did I end? Enable show IP interface. Show spanning tree. So this spanning tree. VLAN 1. You see, all the ports are in which state?
Forwarding
designated. This is the role. Ports designated. Designated is also forwarding. See that? Because why they are all in designated? Because spanning tree status is what? It is actually acting as root bit ID is 32769. This is acting as root. This switch has become root. Let's go to this switch, okay? Show, okay, you see that? The local priority is 32769, same as the above one. So they both act as both. So this one will act as root, this one will act as root. How you break it? I will show you how you break it. See, if both will act as root, what will happen? Spanning tree will not forward the traffic. Remember, guys, if both have the same spanning tree priority, VLAN 1 traffic will go nowhere. It will be in blocking state. But here you can see here, it is acting as designated, it is acting designated. Here, amazingly, at the same time, it is root. How come the designated switch as a root will have a root port, right? It cannot have a root port. Root port is for a port that is trying to find a root bridge, right? You understood what I'm saying? There cannot be root port on the root bridge. Why? Because all the ports on root bridge are designated. The problem here is both are thinking they are root bridges. This one is thinking root bridge, this one is thinking. I'm going to do something here. So, configure P.
But Harsha, in a network, there can only be one root bridge, right?
That's why I'm saying, that is why, because you did not configure spanning tree. Spanning tree is configured by default on all the things. But by default, what is the spanning tree config? Priority, they will all take
32768.
Yes. Here we are using per VLAN spanning tree. Remember? We are not.
Yeah.
We are using per VLAN spanning tree. So here we are using spanning tree priority value not based on the MAC address of the switches. We are using here spanning tree priority value based on the VLAN numbers here, because we are looking at the spanning tree configured for VLAN 1, not for the switches. So VLAN 1 by default is configured with spanning tree priority 32768 on all of them. So I will go here, lesser the priority, that will become root, right?
Yeah.
Less the priority value, that will become the root. So if the priority value is small here, it will become the root. And this will automatically adjust it. Okay? I will show you how it works. Spanning tree, VLAN 1, priority, 32768 is default, right? So I will give something that is lesser than it, 8192. It is smaller than 32768, right? So I gave spanning tree priority 8192. So root bridge is the one that has least priority. So obviously this will become root bridge. Why? Because other switches have 32768 as priority. So 32768 is greater than. Now see here. Which one I configured? Oh my god, I configured. Okay, I configured the master only. So on the core, see on the core, I configured as less priority. Now I will go here. Okay. What will you find here? You will find designated ports. Will you find it or not? Can you tell me? You still find designated ports, but let's go here. Why? Because FA02C and FA03, they are connected to these switches. So between these three switches, this has become root. Between these switches, this will become root, right? I'll go here. Show spanning tree VLAN priority. They're all in designated. See, none of them in root port, right? I will see what I will do here. I will go here and make this switch 819 configure T spanning tree PRT. I have to give value greater than 8192, right? Otherwise this will become priority again. So I will give some value like 9023, okay? Because 9023 is greater than 8192. So I will tell you explain. So this switch has priority of what? I will write it here. So this switch has 8192 as spanning tree priority, this switch. So this switch I am going to give 9023. Okay? This switch what will have 32768 by default, right? This switch will have 32768. So this switch will also have 32768. This switch will also have 32768. So as soon as I modify this switch to 9023, what you will find? You will find 0 root ports on it. You should find 0 root ports on it. Okay? So as soon as I change the priority to 9023, this all ports will become what? Will become, yeah, all become designated port except probably this port. This port might become root port, right? Because it is connected to another spanning tree root bridge. See, so VLAN 1 priority 9023. Okay, allowed values are I will give 1288. I gave 8192, right? I will give 1288. It is bigger than 8192, right? So I'm going here. Now all ports have become what? Designated ports. You see here, all ports have become designated ports. FA02, FA03. And also, now see here, FA01 ideally should become what? Root port. But let us see what's happening on FA04. Show FA4 is also designated. Now, these both are making as designated ports because this switch is making this as root bridge. But at the same time, this switch is making this as root bridge. So if you go onto this switch and look at the ports, you will find designated and root ports both. See, this port G02. Where is G02? This port has become root port. Why? Because this is a designated port. You understand again? I will again run spanning tree on this guy. This both have become designated ports because this port, I need to check the value of the interface. Okay. So I'm going here, configure T, spanning tree, VLAN 1, PRT, 8192. What will happen now? All will become designated ports, right? Why? Because this is also become a
root bridge.
now this has become an alternative bridge. So that is also a bad design. You should never make both core with same priority. You should make this one as 1288, okay? Configure T, double the 8192, okay? 12288. Now you go back here. Now do configure T, spanning tree, VLAN 1 priority. Now I will give its value something. It should give us 16384. I will give, okay? 16384. Now see, there will be no designated ports on this now. Oh, this has become a root. Again, it's running. Let us give it some time. This has again become a root here. Let us give some time to characterize the spanning tree. It takes 30 seconds, okay? Because it is making designated ports all, and this switch will have root ports to these ports. Let us see that. You are understanding the concept, right? How the ports are changing from designated to root once we make a higher priority value. So spanning tree, VLAN 1. You see, root port, alternate port, designated port. What is the designated port? FA03.
Harsha, just one quick question.
Okay.
Now, right, like suppose one switch has multiple routes, right? So now, like, when you're configuring, you're giving us priority, and will the same number be assigned to all the routes? Like, if we have if you take the first multi-layer switch 0, right? It has FA0, FA01, 02, 03, 04, right? Like,
yeah, it has so many ports, yeah.
Yeah.
So this right. So when this has become root, this will all become designated ports. That's why they're all glowing green. So this designated port is directly connected to other ports. So this will also become designated port.
So, but like, when you are assigning the priority, so for all the routes, will it get the 8192 as the priority?
This priority is only for VLAN 1 on this route, on this switch. So priority for VLAN 1 on this interface is different again. Since this is now blocking state and this is directly connected to the other port, this is designated port as well. See here, there is no further loops or switch. It is here at the end of the network. So this port will also become a designated port. I will show you. See, FA03 is directly connected to the PC. It is also designated. Let's go here and see what's the spanning tree here. Show spanning tree VLAN 1. Designated port is FA03. This is the root port. The alternate port is in blocking state. Why it is called alternate block, I will tell you. I'll go to configure T. As soon as FA01 goes down, this alternate port will become root and it will also go to forward state. See, configure T, sorry, FA01 shut. Okay? You see which has become root now? Earlier FA02 is blocking state. Now FA02 is what state? Root state, and it is what it is doing, it is listening. So spanning tree has 3 states, just like we have query packets in EIGRP and OSPF. We have 3 states. It is listening now. It will now, it is still listening. How much time it will take to listen? Can you guys tell? How many seconds for listening?
30.
15 seconds. Okay.
I'm still connected. I mean,
yeah.
we have multiple, right? So only VLAN we are configuring, right now, right? VLAN
Right.
1.
See, show VLAN ID 1. All ports are in VLAN 1. That's why these ports are participating in spanning. That clarifies your question, right? Understood? Only VLAN 1 we are configured.
If all are in VLAN 1, so pretty much everything we should get the same 8192, right? Like suppose if you take the multi-research, if all the links are in VLAN 1, so everything should get the 8192, right? Then?
No, only the VLANs on the switch interfaces where we configured. See, I gave command switch VLAN 1 1288 on which switch. I gave this command is spanning to VLAN to 16384 on switch 0. So all the VLAN ports, one port that are configured on this switch will have that. Okay? You understood? So all the VLAN 1 ports that are configured on the switch will get this priority. All the VLAN 1 that port configured on this ports, all the ports that are in VLAN 1 on this switch will be getting this priority, 8192. You understand? The switch is for some reason still listening. What I'm going to do is reload, okay? I'm reloading the box.
So can we configure how many ports can be VLAN on the switch? So it's all in, we can configure it or automatically.
I didn't get your question. So you're still confusing with the concept of VLAN. See, all the ports are in this VLAN 1. Show VLAN ID 1. See, these ports are configured in VLAN 1. That's why they are getting the spanning tree priority of VLAN 1. I will configure VLAN 2, okay? So I'm going back to the yesterday's class. Here, we have red team, yellow team, right? Let me do here. See.
I understood that, Harsha, but the thing is, right, we thought by default, like only few can be in VLAN 1. VLAN 2, other things we can configure, right? VLAN 1 also can we configure the ports?
Right. See, show VLAN ID 2. We have FA02. Show VLAN ID 1. We have FA0. So it is also on so many ports.
Okay.
But if you look at here, show VLAN ID 3. It is not active on any ports. Show VLAN ID 4. What happened? We configured them, right? We configured them on the trunk, right? Last class. Show interface trunk. Yeah. VLAN. So I configured VLAN. FA02. Okay. So your question is, if there are 3 ports under one VLAN, 4 ports under one VLAN, how the spanning tree will work for those ports, right? That is what you are asking me, right?
Yes.
Okay, I will explain you that. I will explain you now. So, per VLAN spanning tree using a trunking protocol. For example, let me configure a different network here, okay? I'm going to take a switch here, okay? This is a switch. It's a layer 2 switch. I don't want this guy. I want to configure a layer 3 switch, okay? So I'm taking a layer 2 switch here. I'm going to take another layer 3 switch here, okay? I'm going to connect this switches, okay? Fast Ethernet 01, fast Ethernet 01, okay? Fast Ethernet 02, fast Ethernet 02. So loop is formed, right? You all agree with me? Kavya, Kishore?
Yes.
I formed a loop.
Yes.
Okay? Now I'm going here. enable, okay? Configure T VLAN 23. Name primary VLAN. I cannot give space. And configure T VLAN 43. Name primary. Sorry, secondary VLAN. You guys understand what I'm doing here? I'm configuring another VLAN 32. Name tertiary VLAN, whatever it is, okay? Show VLAN. So I configured 23, 32, 43, okay? Configure T VLAN 23, okay? VLAN 43, VLAN 32, okay? Show VLAN. Configure 3 VLANs here also, right? But both switches doesn't know. You see already here the spanning tree is blocking this port. It already prevented the loop mechanism here, right? This port went to down because all these ports are in which VLAN? Which VLAN, Kavya? All the ports are in which VLAN?
1.
VLAN 1. So VLAN 1 is running spanning tree already. See, it blocked one port. This has become root, right? This has become root bridge. So all ports on this switch will be in which mode? Tell me. All ports on the root bridge will be on which state? Designated state. See, designated and forward. Okay. Now our story is not about VLAN 1. By default, VLAN 1 is configured. The spanning tree is running itself. Now we configure new VLANs. By default, spanning tree value for the VLANs we configure should be 32.768 by default. For some reason, our packet tracers are not taking default value. No problem. So, see, no spanning trees. By default, there will be spanning tree instance exist for all VLANs once you configure them. It will take default value of 32.768. Now, what I'm going to see here, configure T interface. What is this port number? Come on, show up the port number.
Harsha, enable the labeling. I mean, you can enable it from preferences.
No, I'm just hovering over it to see what port it is in. Come on. So both FA01. I didn't do anything. FA02, FA02. Okay. So I remember, let's FA01, right? Okay. So interface FA01. How I configure trunks? Can you tell me, guys? Switch port mode trunk. Switch port mode encapsulation. Switch port trunk mode encapsulation. Which .1Q? Right?
Mm.
Switch port trunk allowed VLAN 23, 32, 43. Okay, no shut. So configure T FA02. Sorry, interface FA02. Switch port mode trunk. Switch port trunk encapsulation dot 1Q. Okay. Switch port trunk allowed VLAN. I'm adding VLANs to the trunk. Okay. 23, 32, 43. I cannot use the word add because there are no VLANs, existing VLANs. If there are existing VLANs, in order to avoid overwriting, you will add the command add. write memory. Okay, so interface trunk. Interesting. Have configured trunk rest now. Swipe interface brief. So there are two things that are show interface trunk. Strange. Okay, let's go. Hey, why this port is down? Configure T interface FA 0/2 no shut. Okay. Show interface trunk. Okay, it should show interface trunk. Okay, let's go back here. Configure T interface FA 0/1 switch port trunk trunk port mode trunk switch port trunk encapsulation .1Q switch port trunk allowed VLAN 23 32 sorry 43 no shut interface FA 0/2 I can use up arrows just more trunk encapsulation and no shut control finger exit conf T interface FA 0/2 no shut show IP interface brief control show interface trunk. This is very painful, okay? It shouldn't be happening like that. FA 0/1, no shut. FA 0/2. You know why this is happening here? Because we didn't configure spanning tree. Now this is looking good. Show interface trunk. It should show something. I will show you why I'm very annoyed. We have configured trunk here. See, show interface trunk. I need to get these values, okay? I don't know why it is not showing here. Spanning tree should run on it. Show interface trunk. For some reason, they're not taking the trunk configuration. Why it is not taking trunk cross? Show run. Did we miss any command? Switch port mode trunk we gave, right? Is there anything that we're missing? Switch port. See, show interface trunk, it gives us VLAN which are in which port and all those things, right? Why it is not, and also encapsulation and all those things. So why show run FA 0 and what the extra command that we add here? We did allow trunks here. Why it's not trunking? So trunk allow VLAN. Show VLAN. Because we are doing on the same packet tracer. Show VLAN. Are our VLANs active here? That is important. They're active. Show spanning tree VLAN 23. Well, whereas here we didn't configure spanning tree earlier, right? Yesterday class, like before yesterday. Show spanning tree VLAN 2. See, we didn't configure spanning tree, but it took by default here. Why this is not happening in the switches? You understand what I'm saying? On the switches, spanning tree is configured by default. So what I'm going to do, I'm going to configure the sessions here only, okay? Why to waste time? Okay, remember 0307. So configure T, interface FA03, switch port, mode trunk, switch port, trunk, encapsulation dot 1Q, switch port, trunk, allow VLAN 234, no shut, and this is 0/7 here. Control C, enable conf T, interface FA0/7, switch port, mode, trunk, switch port, mode, trunk, allow definition. What I'm doing, junk cap. Okay, encapsulation doesn't work here. Show interface trunk. Now see, you'll see both trunk. You see both one F01 and F07. When I come back here, see, on FA0 none of them are being forwarded. Why? Because it's been blocked. Spanning tree is blocked it. Right? I'm going to show you something here now. Show spanning tree VLAN 4. Designated ports. Other is blocked. Why? Because both places it is taking same priority value. Spanning tree, show spanning tree VLAN 3. So spanning tree exists. What the heck? Why it's taking spanning tree for some? It says tree no exist. Here it does not exist at all. So it is running spanning tree here itself, assuming all these ports are designated ports. Show spanning tree. See, it made F07 and 2 designated ports because it made this bridge as a root bridge. So what I'm going to do here, configure T, spanning tree, VLAN 2, priority 8192. Okay, I'll do the same with 3, same with 4. Okay, now I'm coming down here, I'm changing the priority to higher one, configure to, I'm configuring default priority here, spanning tree, priority, VLAN, VLAN 2, priority 32768. Default, by default it should create like that. Okay. Show spanning tree VLAN 3. No instance created. I just created a spanning tree VLAN priority, right? See, I just created spanning tree VLAN here. Let's see what. I just created here. Okay, configure T. Spanning tree VLAN 4. Spanning tree VLAN 2. Spanning tree VLAN 3. I already gave its priority. Show spanning tree VLAN 4. Very good. So at last it took the spanning tree. Okay. So 32768 plus 4, 3272. Okay. Let it run the spanning tree. Okay. Now the important fact that we have to understand is how the things change here now. I'll go back here. Show spanning tree VLAN 4. has become designated state now. See, 0, 1, 0, 3. What are the ports here? F01 and 03, right? Right? Both have become designated ports now. Why? Why?
Because it became the root bridge.
See, I will tell you one thing. These are trunk ports. The trunk ports are not supposed to have spanning tree configuration here. I will tell you something. Trunk ports are more than one VLAN. They're supposed to not have any spanning tree configuration, which is good. Now, what you have to look at here is both are now active. Can you tell me why, Kavya? Because these are not access ports. These are not single VLAN ports. These have trunk ports. On the trunk ports, you will not put what you call spanning tree on the interface. So spanning tree will now happen. Now you look at here. I will do show interface trunk. Spanning tree will happen per VLAN, each VLAN. So here you see FA01 is forwarding. Okay, FA03 is also forwarding. Can you tell me why? Because they both are trunk links. They have to forward it. And see how 4 ports came up? There is a loop formed here now. But we have to look something here. Show, I will show you something. Show spanning tree VLAN 3. What is here? It's a designated state. Now I will go to the bottom link. I will do here show spanning tree VLAN 3. Here it's saying the root. What is the state here? It's nothing. Can you why? What is the root bridge it is showing? This MAC address. Okay, let's copy this. Let's go back here. What is the root bridge? What is the shows spanning tree? What's the root bridge address here? Different. So these two are running each their own spanning tree. That is why the spanning tree is not working in this loop, because there are trunk links. So this is one bad design. You cannot run 2 trunk links from both one core switch to the aggregate switch. The spanning tree you cannot never block. Now I'm going to take this link down. Okay. Now I'm going here. See, you see how different scenarios of spanning tree I'm covering. Configure T VLAN 2, VLAN 3, VLAN 4. Okay. Show spanning tree VLAN 4. Nothing exists. 3. Nothing exists. 3 there is already exist. Or it took default value. Okay. Let's see the 2. It does not. Configure T spanning tree VLAN 2. Okay. Spanning tree VLAN 2 PRT. What PRT I'm going to give you now? What PRT I'm going to give? This guy has 8192. Okay. This guy has 8192 as a PRT. This guy has here. What is the PRT here? We have to give which PRT? The next one. What's the next PRT? twice 811. 1288. You know why? Because if priority of these both routers matches, again there will be trunks will not understand. These both trunks will work as forward ports. Again there will be a loop formed. So I'm going to give the secondary spanning tree priority. Okay? You guys are getting what I'm trying to do here. I'm going to give you a big picture here. And then next we have spanning tree prior 4, then 3, right? First we have to enable spanning tree priority. Then you have to give the priority. What is the priority value? This guy. So now show spanning tree VLAN 3 priority. Now see, we have enabled spanning tree, okay? This guy has got some priority. Now we have to come here. This priority and this priorities are matching now, right? I have to configure the trunk link also. Both these switches have same priority now, right, Kavya, Kishore? What is the port number here? Why am I unable to see the port number? FA03. Okay. To show IP interface. 01 maybe. Configure T to the FA01. Which port trunk? Yeah, I'm going to do one other command. FA01 -2. Come on, it don't take that. Switch port trunk mode. Switch port mode trunk. Switch port. Okay, this command is rejected. Okay. See here, the trunk encapsulation is auto. So we have to change the trunk encapsulation. Switch port. Are you able to see my screen?
Yes.
Switch port, trunk encapsulation, .1Q. Switch port, mode, trunk. It took the command now. Switch port. I understood why it didn't took trunk there. It was in auto. That's the reason. Switch port, VLAN, add, port, trunk, allowed, VLAN, 2, 3, 4. Show interface trunk. Okay. Now, are you able to see at my screen?
Yes.
See here, we have added the VLANs to the trunk, but they are not forwarded. Spanning tree is blocking them. Why? Because, I will tell you, there is a reason. We have to go here. I'm going to configure FA03, okay? Interface FA03. Okay, switch port mode, switch port trunk, encapsulation, switch port trunk, allowed, VLAN, 2, 3, 4. Okay, now conf T, spanning tree VLAN to VLAN 2 priority 32786. Okay, sorry, 32768. My bad. I'm making them all default. Why? Because the top one has, see, two, 4, 3, sorry. Now see here, show spanning tree VLAN 3. Okay. Now this is also forwarding. Okay, very good. So now see here, the priority I gave to this switch is 32768. So this one has highest priority. In case this switch goes down, this will take as root bridge. If this root bridge takes down, this will take as root bridge, right?
Yes.
I mean, not root bridge. This will both. There's nothing, right? If you lose both core, you are out of network. So between these three, how the spanning tree is working now? I will go here. You will see here at show interface trunk. You see here there are 3 trunk links. 1, 2, 3. Ideally, this should be blocked because this is a primary, this is secondary, this is root bridge. Now, it has not formed a loop, right? That is the reason it is thinking it shouldn't block. So, I know why it is not blocking this port, because there is no loop formed yet. So, we are missing some configuration, redundancy between primary and secondary. Okay? How this switch knows the switch has the priority. You understand what I'm saying? If the switch has to become root, bridge with respect to this switch, it will become. If the switch has to become secondary root with respect to this switch, for this switch, how it will know the priority on this switch, right? Both should communicate. You understand what I'm saying, guys, here?
Yes.
So, going to the FA03, configure T interface FA03, switch port mode trunk, switch port trunk encapsulation dot 1Q, switch port trunk allowed VLAN 2, 3, 4. Kavya, any questions so far? I'm trying to create a loop here now to show how primary and secondary spanning tree failover works. Okay, on a big scale when you're running more than one VLAN on a trunk link. Okay, configure T interface FA0 by 3, switch port trunk allowed VLAN 2, 3, 4, switch port mode trunk, switch port, sorry, it's not one, switch port trunk encapsulation dot 1Q. Now go up, show more trunk. Now it works. Show IP interface. Sorry, show interface trunk. Okay, there you go. This is what I was trying to show you. Now loop is formed. Okay. Now loop is formed. Now it has blocked on this port. This is very interesting. Ideally, it should not block this link port. It should block this link port. Why? The VLANs on this trunk coming from here as what they have? They have higher priority. But we have configured them in the first place, right? That's why it is blocking this port. Now it is rerunning again. See? Let us see the interface trunk. See, it has 2 uplinks, this one and this one. If the setup works like this, it's going to form a big loop. It should block this port. Why? Because secondary has higher priority, so it should treat this as a root bridge. Now I am thinking, why this switch is not blocking this port? Show interface trunk. Why all ports are forward state? Show VLAN 4. Show VLAN ID. Show, sorry, spanning tree VLAN 4. See, one is in root, other should be in blocking state. It should not be forwarding. Okay, I am very confused why it is doing that. Why the spanning tree is not communicating between 3? So let us go here and see if the spanning tree value is same. Okay, spanning tree spanning to priority. Okay, cost 38. You see here port to bridge priority. Bridge ID is 32770. It is still considering itself as no root ID. It took, see what is the MAC address here? This one, right? Control C here. Let us go to the core and see what is the root bridge MAC address there. Show spanning tree. Let me paste this here. Okay, so it is catching this as a root ID. Okay, let's go here. Show spanning tree. What's the root ID here? It is also considering this guy as a root ID. My question is, why then it's not blocking any ports? Why the spanning tree is not blocking any ports? What else we are missing? Control Shift Z6. Show interface trunk. This should not be forwarding. In a second before they were forwarding, right? What I'm going to do is I want to rerun the spanning tree. Okay. How I'm going to rerun the spanning tree? Configure T interface FA0/3. Shut. No shut. Show IP. Show IP interface brief. Show interface trunk. Oh, anyways, FA03 is down. It is still coming up. Show IP interface brief. It is up now. Now let's see the spanning tree state. It's again looping. This is interesting. That is because what I'm going to do now, take this loop. What I'm saying? Now spanning tree should run between them. So what I will do further, I want to remove the confusion for these switches. Okay, save it. Frozen. I will try to troubleshoot why the spanning tree is not working. I have given the priority 8194 here and 8195 here.
Monday we have a class, right? Then
Monday I believe Dinakar will take that class. So yeah.
Okay.
It shouldn't be blocking. Yeah, one more concept, VTP is there. I don't know if you guys, it will take 5 minutes for me. If you want, I can show you what is the VTP. I'm configuring new VLAN here, Kavya. See, VLAN 4546, VLAN 47, okay? If I do here, configure T, VTP, mode, server, okay? And I go here and if I configure it as configure T, VTP, mode, client. I have not configured VLANs yet, right? 45, 46, 47 yet. This should take the VLAN automatically whenever. Understand what I'm saying? This will get all the VLANs that I configured here. Now I will configure VLAN 567, VLAN 345, end. Okay, write memory. Let's come back here. Let's show VLAN. So this should take those VLANs ideally. Show VTP status. This is client, right? So it should ideally take the VLANs that I configured on VTP server. Show VTP, show VLAN. So those new VLANs are configured here. It will take some time to update. it should show up in here. Also, I will configure VTP domain. Let us call it as CCNA. We'll also configure VTP domain here. I will show you saving it file, open samples. There are no switching. Regarding remaining classes, Kavya, if you guys have some topics that are outside the CCNA, we can discuss. If you have, let us see how it works. Let's say Daniel take in charge of wireless and all. Once he finishes, if time permits, I will teach all the remaining topics like point-to-point protocol. There are so many things like configuring serial links, and also I will configure frame relay, all those things. This is interesting. You guys can drop. I'm unable to figure out why the VLANs, though configured properly with the spanning tree, they are not running it. So there is one way I can do it. It's going to interface and applying the spanning tree there, but putting spanning tree on the interface command is not advisable. What are these ports?
I think packet tracer problem, Varsha.
Right. I have showed you, right? I may show. Spanning tree VLAN 2. Sorry. See here. It is blocked. So this one is forwarding, this guy is blocked. That should ideally work when I configure for the trunks as well. I made this switch as primary, this as secondary, and then spanning tree make sure that loop is blocked from the secondary priority switch. As soon as if I block this port, right, this will go green. I will show you. See. As soon as the port FA01 goes down, configure T interface FA01 shut. This will go to forwarding state. You see that? So the blocking state, right? Forward, it is now listening, but eventually this will go to forwarding state. Okay, so I'm concluding this class now by saying a few notes. So there are other ways, other spanning trees also. Legacy STP, per VLAN spanning tree, per VLAN spanning tree plus, and also I give you RSTP is also one, and RPVST plus, and MST. Whereas RSTP stands for Rapid Spanning Tree Protocol. These are all further enhancement of per VLAN spanning tree that we are using now. Okay? So if they ask what is the BPDU format, you should learn BPDU will have root ID, root path cast, port ID, message age, maximum age, hello timer, forward delay. So there is a BPDU, okay? BPDU has a format, okay? It has a port ID value, it will give as 16. For root ID, it will give 64. Okay? And also there are default timers. Hello timer is 2 seconds. Forward delay timer is 15 seconds. Maximum age of a spanning tree is 20 seconds. Okay? Port states. There are many port states, okay? Disable, blocking we all know, listening, Right now, that's what it is in, right? Which state it is in? Listening state, LSN. It is still listening? Yeah, it's still listening. I don't know why. How long it will listen, that one. The packet tracer, I cannot trust it. So learning, forwarding. So it should move from listening to learning state and forwarding state, ideally. Okay? So it's forever staying in listening state. Configure T, FA01, no shut. Interface. No shut. But see, blocking state is going right away. It's again listening state. The designation state is again listening. It is taking too much time in the listening state, but ideally listening state should be how many seconds? 50 seconds. Okay. So this mechanism is working well for per VLAN using layer 2 VLANs, but for the trunks, it is not working the same way. I need to troubleshoot why. So by now you might have all understood how the default, what's assigned to default value. If at all some member of the loop is forming a root or a root bridge, how I'm verifying it? I'm going it and copying the MAC address of from the spanning tree value and going to each member and see whether it is recognizing the root bridge as root bridge by putting the MAC address there. And see 0664, yes. It is recognizing this root bridge as root bridge. So whenever you do spanning tree VLAN ID and you see the root bridge address and pre-RT, it should point to this root bridge. At least it is pointing to the root bridge, and the backup bridge is also pointing to the root bridge. So this is how you design your mechanism. On the troubleshooting commands, you always make sure is show interface trunk, because after you configure trunk, you see it's nothing showing here because we didn't configure any trunk here, but here we configured trunk. So show interface trunk. When you show interface trunk, both ports should not be forwarding. That means it is following a loop. Or that means both core has lost communication. That is a very good troubleshooting steps. Both ports from the access, from the distribution switch or access switch is forwarding to the core means the loop is formed, and it's very critical for your network. That's all, folks. For any other further questions, please let me know right away. Show VTP mode. So VTP status. VTP is in server, okay? VTP domain and CCNA. Let's come back here. Control C. Show VTP status. VTP status is client. CC server. So if you add some VLANs to the server, VLAN 34, VLAN 35. VTP client should also accept it. Yeah, you see that? I did not configure on the client, right? Kavya and Kishore?
Yes, yes.
So, you see, I have configured in the same domain on the client, and it took it. So, what I'm going to do now is, I'm going to, what should I do? I should connect. Show interface, please. I probably configured 03 also, right? So going from 03 to 01, right? See, Kavya, here also VTP is client mode, okay? Show VTP status. It is in server mode. I'm going to do C. Enable conft VTP client. Sorry, conft VTP mode client and VTP domain CCNA and show VLAN. something else I'm missing. Oh, the port is not up yet. Conf T interface FA0 by 1. So shut. Show VLAN. Show VLAN. Show IP interface, please. For some reason the port is still not going up. Now it's up. Now do show VLAN. Show VTP status. TP is client, VTP domain CCNA. Show VLAN. It should update from the client. Show VTP status. VTP is nothing but VLAN trunking protocol. Did we configure this as a trunk? We have 10 VLANs here. Configure T, do show interface FA0 by 1. Do show run interface 0 by 1. Oh boy. We did not configure the trunk. See here, simple. I no need to add all the trunks. Interface FA0 by 1. Switch port, mode, trunk. Switch port, mode, trunk, mode, trunk, encapsulation. Only to add encapsulation, same layer. No switch port, mode, access. Now see here, I did not add any switch port, trunk mode, allowed VLANs and VLAN numbers, right? And show run. See, I did not add any. Oh my boy, why it's still showing access VLAN? Configure T interface FA0 by 1, no switch port, access VLAN, no shut, switch port, mode trunk. I'm just making the switch port mode trunk. I'm not adding any VLANs to the trunk interface, but it should show VLANs here. Show VLAN. All the VLANs should come ideally and join the VLAN database. Show VTP status. You see, VTP is client CCNA 6. This VTP will communicate with this one, which is down now again. And it will carry all the VLANs that configured on dynamically on the code. See, VLAN, I will say 781. So I'm going here. I will do show VLAN. Show VLAN. 781 is added to the VTP data. I did not even configure on this switch. The same should proceed and add to the downlink switch. See, show IP interface brief. VTP status. It's not fetching the domain from it because this port has some problem communicating to it. Now it should work. Client CCNA. Okay, VTP traps. What is it? Okay, that's how ideal VTP should work. So at least I'm able to show you maximum support 255, configuration revision 10, VTP version 2. I'm not sure what VTP version we are using. Also 2. Configure revision, none of the revisions have happened here. So they have to propagate from here to here. Show interface trunk. VLANs in spanning tree state and not true. Forwarding. What happens to other VLANs? Okay. So you understood, right, how the VTP domain is sharing its VLANs with the VTP client. So if the domain, if you create the same, and if the server is configured with certain VLANs, client will also observe the VLANs. Okay. That's how VTP client and server model works, or server client mode works. There is another mode called transparent. The transparent, we have to again manually add all the VLANs to the trunk, even if there are 100. There is a very drawback of putting VTP server and client mode in infrastructure. If you have 200 switches, the VLANs will be propagated to all the switches even though they are not required to be present there. So unnecessarily you are creating so many VLAN broadcast on. End of the switching. Any questions? I believe scenarios in spanning tree, like making them primary and secondary manually, and it's working fine. Okay, let me stop the simulation. Okay, this guy is working fine otherwise. Otherwise, by manually giving priority on this one and this one, that you have to do, because by default it will take default priority. So if you are configuring primary and secondary spanning tree priorities on the core, so you have to give the smallest to the primary, the least smallest to the secondary. Remind that, make sure that both the priorities that you are giving on both primary core and secondary core are less than default spanning tree priorities. That is the only way you make them as root bridge, sorry. So primary root bridge, secondary root bridge. That you always should keep in mind. So whenever you are configuring VLANs for the first time, make sure they don't take default value. They take on the core. I'm saying on the core. Whenever you are configuring VLAN on the access switches, don't worry about altering spanning tree priorities on them. Let them take default priorities. They will somehow make sure they will reach the core bridges as root bridges. You understood, right? End of the class, guys. Thank you.
Yeah. Okay, Harsha. Bye-bye.
So